Welcome to Algebra 1 Honors, Week 5. Please make sure to fill in your table of contents. Complete your warm-up for the week. And I wanted to review from the summer work. This is not a page number. You'll just please watch. I do want to insert something that I did not require you to do on the summer work. I will expect you to write your answers in this form. I'm going to solve all of these. I'm going to use basic algebraic skills to solve these. Just because I have an inequality does not mean that I solve it any differently until I get to the very end. Going to subtract 8. Negative 3 is greater than negative 2n. Going to divide by negative 2, and here's where many students for the summer work would mess up on this problem. A negative divided by negative, of course, is a positive. I divided both sides by a negative number, therefore the greater than symbol must become less than. And then a negative divided by negative is a positive 1. Negative 2 divided by negative 2 is a positive 1. Now, I want to write this way. I want to think about it, what it would be like on a number line. You do not have to graph this. It just says to solve. But I want to think about what it would look like on a number line. 1.5 is what that is, and it would be open, shade to the right. Now, I want you to write your answers in interval notation. I'll put the link for the video from this summer on here as well. Interval notation, you're talking about going from negative infinity to positive infinity. Where does this number line start being shaded? It starts being shaded at 3/2. Because 3/2 is an open circle, you put a parenthesis. If it's a closed circle, you put a bracket. So I'll put these here. And where does my pencil number line stop being shaded black? It never stops, so it goes to infinity, and infinity always gets a parenthesis. So I want our answers to be written this way from here on out. This is interval notation. So please be sure to use interval notation for all inequalities from here on out. Okay, let's look at the next one. Our variable was eliminated, and in the summer work there were a few people who put 1h, 6h minus 6h, they'd put 1h, but that actually gives me 0, they're gone. Is this a true statement or a false statement? Is negative 18 less than 1? That is true. And if it's a true statement, remember we put infinitely many solutions. If you were to color that on a number line, let me show you what that would look like. Where's my number line shaded? It's shaded from negative infinity to positive infinity. So if you have infinitely many solutions, you're going to use negative infinity to positive infinity. Next, I'm going to add 4p. I did not divide by a negative number, therefore my inequality symbol will remain the same. 21 divided by 7 is 3. On a number line, equal to, greater than or equal to 3, and if it's greater than, you shade to the right. Remember, negative infinity to positive infinity is how a number line goes. Where does my number line start being shaded black? It starts being shaded black at 3. Also remember, since I have a closed circle, I need to use one of these brackets. So The closed circle is on the 3, so I put my bracket on the 3 this way. Where does it stop being shaded black? Infinity. And remember, infinity, negative infinity always gets a parenthesis. Combine like terms. Move your 3j. The j's are eliminated. Is 6 less than 2? No, that's false. And you do just write no solution for that one. There's not an interval notation. The last one, move my 3w. Is 36 less than or equal to -4? That is also false. So the answer to 10 is also no solution. So again, you did not have to write those down. You do need to know how to answer in interval notation. Let me do a quick example. So this is just extra. What if you had a number line that looked like this? It was shaded on the left side and shaded to -5. How would you write that in interval notation? Remember, negative infinity to positive infinity. Reading from left to right. Reading from left to right. Where does my number line start being shaded black? Starting on the left, it starts at negative infinity. Remember, positive infinity and negative infinity always get a parenthesis. Where does it stop being shaded black? At -5. At -5, do we have an open circle where I'll use one of these symbols, or do we have a closed circle where I'll use one of these symbols? Well, it's open. Which symbol do I use? You use the symbol that would match this, would close this off. So you would definitely use that symbol, the right hand parenthesis. And so this written in interval notation is from negative infinity to -5. You do need Student Journal page 47. It says find the value of k for which the solution of the inequality is all real numbers. Okay, so all real numbers also means that infinitely many solutions. I'm going to distribute. As I think about this, I want to remember that I want the variable to go away. So I want to be able to add 12r to this side to 4kr. And I want that to make 0. I want that to make 0. What number would k have to be? We'll ignore the r's for now. What number would k have to be for k plus 12 equal to 0? I know those are like terms already, so I don't really need to include that r here. What would make that happen? Let's subtract 12. Divide by 4. If k is -3, then these two would cancel out and make 0. Let's see if that's right. 4 times -3 is -12, -12r. -12r plus 12r, is that 0? Yes. Now let's see if what's left will be true. If I put -3 in for k, will that make a true statement here? I'm going to write over here in this margin. -5k greater than or equal to -9. I want to know if that's true. If k is -3, is this true? -5 times -3 is 15. Is 15 greater than or equal to -9? Yes. So k has to be -3 to make the solution to this inequality all real numbers or infinitely many solutions. Okay, let's look at number 12. Number 12 is very similar. I have 2kx minus 3k less than 2x plus 4 plus 3kx. The first thing I want to do is to get all the k's on one side together. So I'm going to subtract 3kx to the other side. 2kx minus 3kx is -1kx or negative kx. You can say -1kx, but don't put that one there. It's understood to be there. Bring down minus 3k less than 2x plus 4. So again, I want to move this 2x. I want to subtract 2x over here to this negative kx. And I want those to cancel out and make 0. So let's do what we did on this previous problem. Let's subtract 2x. If I subtract 2x, I want to get 0. Okay, so I'm going to forget about the x's for now. I want negative k minus 2 to equal 0. Add 2 to both sides. I want negative k to equal positive 2. Divide by -1. I want k to be equal to -2. Let's see if that works. If I put, because if those go away, I want this to be false. -3 times k plus 4. Let's see if it is. -3k less than positive 4. I want to know if this will be a false statement. That's what I'm checking for. -3 times -2, is that less than 4? And I want it to be false. Is 6 less than 4? No. So it is false. K would have to be -2 in order for this to be an inequality that has a solution of no solution.